Bevy is a game engine that has no UI, and it is one of the pioneers of ECS, a programming paradigm that aims to be decoupled and reusable. What does that mean? I don't know. We're about to find out. I just want to learn Bevy because I want to learn new stuff and get better at making games, so it's probably going to be a good challenge. I'm actually going to make this game, which is a top-down shooter. So this is the Godot version of the game. I can move around, aim, and shoot. I'm not going to recreate the lighting effect, but everything else should be there. Now, I made this game before in Raylib and Godot, so I have another library and another game engine to compare to Bevy. What's going to be really fun is for you guys who are veterans of Bevy to tell me the right ways of doing things after I screw up. Well, so let's go. So I'm at the website. I have to click on Get Started. Okay, that's a lot of text. So I just realized I also need Rust. So let's just download this. Okay, a command line. That means we are real programmers. I guess I'm just going to proceed with the standard installation. Okay, it seems it has installed correctly. So we have some commands here to set up Rust, and I don't know much about Rust, so I hope I don't make a huge mistake here, but if I do, let me know. I have created a new folder for Rust on my system, and I'm just going to simply open this in a terminal to run the commands. Okay, so apparently we can create a new Rust boilerplate code by just running cargo new top down, cd top down, and now I'm gonna make mistake number 1, use VS Code. Yes, I trust the authors. So we have source main.rs, which stands for Rust, and cargo.toml. Alright, so this seems to just print hello world to the console. Let's use our beautiful cargo run. Indeed, we have printed hello world to the console. Does that mean I can include Rust in my resume now? One last thing we gotta do in VS Code is set up Rust Analyzer install. Now we don't actually have to do any programming. VS Code will do everything for us. Okay, so we can now include Bevy here using cargo. Alright, seems like it worked. Bevy is telling me to add this to my cargo.toml file. Okay, now I simply have to use cargo run again to build the engine. They did warn me that this could take some time. Okay, now that's complete. So Bevy actually creates these so-called apps, and this is what it looks like. It includes everything from Bevy up here, which includes app, creates a new app instance and runs it using the run function. Let's see what this does. Nothing as expected. Well, then what are the next steps? Oh yeah, I heard about this entity component system paradigm, which is often shortened to ECS. ECS is a software pattern that involves breaking your program up into entities, components, and systems. Entities are unique things that are assigned groups of components, which are then processed using systems. Sounds simple enough, but I'm sure I'm wrong. Alright, so one entity might have a position and a velocity component, whereas another entity might have a position and UI. Yeah, so far this looks similar to Unity. Systems are logic that runs on a specific set of component types. You might have a movement system that runs on all entities with a position and velocity component. Okay, so this is where it differs. I will pretend I understood, and to create a component you just derive the component, and you derive this trait in a struct. Okay, so this is similar to C actually. Systems, normal Rust functions. Oh, I see what's happening here. It's calling this function for every entity that has a position component. Entities, a simple type containing a unique integer. Oh wait, I'm confused. Do you create an entity like this? How do you create an entity? Struct person. So person is a component, it seems. Oh, it seems like you can only create entities by calling commands.spawn and providing the components that are going to be in this entity. Oh, that's quite confusing actually. Anyway, let's backtrack. I'm going to add this. Hello world. So I have to add this system to my app using the update schedule, which runs every frame. So if I run this, will it run every frame or just once? Just once. Okay, this is very confusing because it says update. Very different from Raylib and Godot and all the other engines, but it works. Your first components. Okay, so I actually create the person component. Boom. I create the name component. Boom. We can then add people to our world using a startup system. Startup systems are just like normal system, but they run exactly once. You see, I expected this, but I also expected update to run every frame. Oh well. Now register the startup system like this. Alright, bet. See, I expected startup to run once when the app starts, but update also does that. Your first query. We could run this now, and the add people system would run first, followed by hello world. But our new people don't have anything to do yet. Let's make a system that properly greets the new citizens of our world. Yes, sir. Alright, so we created the add people system, which is a startup system, and now we're creating just a regular system for greeting people. You can interpret the query above as iterate over every name component for entities that also have a person component. Interesting. So we actually run logic for every component, so we don't really care much about entities. We build them here, and then they basically are controlled by their components, so we don't care too much about an entity. This is very confusing, very paradigm shifting, and very brain hurting all at the same time. Unless we can cargo run this. Cargo run. Well, I forgot to add the systems here by using a tuple. I don't know what a tuple is, but I'm assuming it's just like more than one thing packed together. So instead of calling only hello world, we have coupled these two together, and now we're calling both, or adding both. Sorry. If I run this now, hello world, hello Elena, hello Renzo, hello Zane. Cool. Your first mutable query. If we want to change the names of some people, perhaps they got married, for example, we can do this using a mutable query. So I've heard this. Rust apparently makes every variable constant by default, so you can't really change their value, so you have to use the mute to make them mutable. Okay, so let's try to understand this. So this is a mutable query and mute name. Oh, so here we used and name. I don't know what the ampersand stands for. With person. So for every entity that has name and person. And if the name is equal to Elena Proctor, we change it to Elena Hume and then break. So we stop the for loop. So this is only going to affect Elena. Don't forget to add the system to the update schedule. Alright, I'm gonna freak out. Why the hell does update only run once? Alright, update. People, chain, run, Elena Proctor. Shouldn't it be Elena Hume? Oh, I'm stupid. So this is update people, and this is greet people. Run. Elena Hume, she's married. One of Bevy's core principles is modularity. All Bevy engine features are implemented as plugins. Games themselves are also implemented as plugins. This empowers developers to pick and choose which features they want. Don't need a UI? Don't register the UI plugin. Oh, that's neat. But I'm going to go with the default plugins. Yoink. Hopefully we see a window. It took some time, indeed I see a window. And what the fuck? What? You should hopefully notice two things. A window should pop up. This is because we now have a window plugin. Your console is now full of hello messages. Yes, this is because default plugins adds an event loop. Oh, I see. Our app's ECS schedule now runs in a loop once per frame. This is so confusing, brother. Why do you call it update before if before it didn't update? Well, I digress. It's working. My first plugin is just going to be hello plugin. That's kind of boring, but alright, why not? So we create our hello plugin and we add it to our plugins. They said I could do this. Hello plugin. See, I'm getting good at this already. This is not in the documentation. I am improvising. I added them both as a tuple. Oh, they say it right here. Implement plugin for hello plugin. Alright, so apparently plugin is an interface and we're implementing in the hello plugin struct. Yes, indeed. Alright, why not? So on our build function, which probably comes from the plugin interface, we are adding our system to the startup schedule. The system being, of course, add people. And we're also adding to the update schedule the hello world, update people, greet people, blah, 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 blah. This should be the exact same thing. That's cool. The entity and component data types are great for representing complex, queryable groups of data, but most apps will also require globally unique data of some kind. Here are some examples of data that could be encoded as a resource. Elapsed time, asset collections. Oh, that's very similar to Godot's resources. Okay, so in our greet people system, we actually now need a time resource. The delta field on time gives us the time that has passed. Yes, I'm very familiar with this. But in order to run our system once every 2 seconds, we must track the amount of time that has passed over a series of updates. To make this easier, Bevy provides the timer time. Alright, so this is basically exactly what I do in Godot, but way more complex. I know it's for a good cause, so I'm adding this probably up here. So this is a resource, greet timer of type timer. Yes, I understand. So now we have to update once again the greet people function. This time we require not only a time resource, but a timer resource that we can modify. If timer.tick just finished, we print. Okay, but where's the 2 seconds? How are we going to make this run every 2 seconds? Oh, here it is. When we implement the resource here, we actually pass in some stuff. So we insert the resource, greet timer from seconds and repeating. Yes, looping timer. Yeah, this is very similar to Godot. Okay, so now we should be able to run this and only see hello messages every 2 seconds. Yeah, I'm assuming it's working. All right, now we're on our own. We have to create a top-down shooter and man, I think I'm going to take a break. That's a lot to take in. I feel more than overwhelmed. I feel scared. I'm going to continue tomorrow, guys. Okay, we're back in a new day. Where were we? Oh yeah, now I basically have to make the entire game. I guess the first thing I'm going to do is change the background color. Bevy, change background color. Use the clear color resource to choose the default background color. And this color will be used as the default for all cameras. Note that the window will be black if no cameras exist. Oh wait, so I need a camera. You must spawn at least one camera. Commands.spawn camera 2D bundle. I guess I gotta make a new system called add cam, and I gotta get the commands like we did here. And then I can finally call commands.spawn camera 2D bundle default. So I'm gonna add this system at the startup together with add people. Add cam. Why does it keep adding everything? I just need the name of the system. Alright, I assume I have a camera now, but I want to change the background color. Insert resource, clear color, and then I provide a color. I think I'm going to do this directly in here. Insert resource, clear color with a color. Oh, we can actually choose how we're going to represent this color. Let's just go with RGB. Why is it like this? Use of deprecated associated function, color RGB. Use color sRGB instead. sRGB 1.0. 1.0, 1.0. Oh my god. We have a white window, ladies and gentlemen. I'm actually gonna go for a gray look, so 0.2. Perfect. I'm trying to match Godot's background. Okay, so now I have to figure out how to render an image. Bevy, how to render sprite. So I found a Bevy example here. Spawn sprite bundle. Well, let me create a new folder here, and I'm gonna call this assets. And I'm gonna drag and drop my player sprite in here. There he is. So now in theory, I just need to spawn a sprite bundle and we're good. I'm actually going to call this setup because I kind of want to do everything through here like I see in most examples. Do the sprite bundle, and within the sprite bundle, I can have this texture in here. Texture, assets, player sprite dot png. Default asset server.load. I forgot about this because I don't pay attention. Okay, friends, we have loaded the asset in, but how is it going to show up on the screen? It's not. Maybe this isn't the correct path. Should I try something like this? No. But how do I know the right path? Bevy will load your assets from the ./assets folder by default. Oh my god, what? So I just say player sprite? Well, I have been lied to. Well, I guess this means that it's not inside the source folder, but actually on top. So I can actually cut this and paste here. So assets is now outside of source, which makes sense. And if I run this, oh, it's always my fault, isn't it? Okay, cool. We are now rendering the player, but how do I change the sprite's position? Guess we have to find out. I guess I need a player component. So let me actually clear this up. I'm going to remove the hello plugin, the greet timer, and the person, as well as the hello world, and I'm going to remove all this. So all we have is our resource and our setup, and I guess we don't have hello plugin anymore. Derive component struct player. So now we have our player component. We are going to spawn player and also a sprite bundle. Okay, so I assume this is spawning my player. Now I actually need to move the player, so I gotta create a system sprite bundle with player. Sprite bundle is not a component. Yeah, I guess my logic is flawed here. So apparently all Bevy's built-in bundle types include a transform component. So we actually filter by transform with player. For transform in query, I've noticed that in the example they use $query. I'm gonna do the same. I don't really know why that is. Maybe I should have learned Rust before this. Anyway, the transform component has a translation, rotation, and scale. Yep, our player is gone, and I bet that if I put something like 100 here, we actually can see the player. Oh, there he goes. So I'm actually going to separate this into a spawn player system. Again, we're going to get the commands. I'm just going to take this and paste it here. This is just for organization's sake. I don't know if this is good practice, but I actually am going to use a speed here. Now I got to specify a speed. Let's say I want 10. So how do I use the speed? And mute player. Can I access both of these? Mute player, for example, and then use player.speed. So now if I spawn him with a very small speed, like 0.1, he is moving very slowly. Cool. I heard I can also implement a resource here, time, res, time, and then multiply this with time dot delta seconds, I guess. And there it is, my friends. I believe this is now working as intended. So now we just need to tie this movement to keys. Bevy input. Okay, so it's a resource. Yoink this. So this is the basic if keys.pressed, w is being held down. You gotta do transform.y plus equals player.speed times time.delta seconds. So now we should copy this 3 more times. A x minus equals s y minus equals d x plus equals. I know this is very ugly. So this is not transform, it's transform.translation. Very common mistake from me. Holy cow, it's actually working. I don't know why this feels so exciting. I guess it's because Rust has always been so difficult for me, and Bevy has always been so cryptic, and ECS has always been so daunting. But here I am, dude. I made a character move. Next up, we need to aim. So let me start by doing fn aim. And as always, we're gonna need a query. I'm just gonna copy this. Now I need the mouse position. Bevy mouse position. Correct way to fetch mouse position. That sounds like what I need. I don't know what's happening here. Mouse cursor position. Use this if you want to accurately track the position of the pointer / cursor. So I can actually copy this logic, and instead of printing, maybe, just maybe, I can actually return said position. Oh god. Ended up going on a tangent here about this little guy, and this is Rust related. Apparently Rust doesn't have null pointers or something like that, and we need this when something could be null. To be honest, not even I understand half of what I just said, but I'm just going with it because we actually have a cursor position right here, and I don't need this else. With the cursor position, we can finally do transform.lookAt, target being position, of course, up actually being vec3, new 0, 0, 0. Okay, so it expected a vector 3, of course. Let final position equal to vector 3 new x being position dot x position dot y 0 final position. Let's test this. So I forgot to add this here, but I realized it quickly, so I didn't waste much time. Oh no. My player is gone. So I realized that lookAt doesn't work for 2D. So we're gonna go the old-fashioned way, the same way I did with raylib, which is using atan2. To use this, we need a difference between the two. Mouse position minus the player position. And I'm gonna get the player position here by using the transform. Player position equals transform dot translation player position. So this is our difference. Our angle is gonna be difference dot y atan2 difference dot x. Of course, for Bevy we need more than this. Quaternion from axis angle, this axis, and this angle. Oh boy, man, that was a ride. Let's test this. It's been 2 hours of tinkering, and I have arrived at this final result. I borrowed from this gentleman in Stack Overflow, and the idea is that we get the window and the camera through queries, and then we use the window to get the cursor position, and we use the camera to convert that into 2D coordinates. And this gets the direction that the player is facing by getting the local y and truncating to remove the z-axis basically. Now we're calculating the difference between the two, again, getting the position, truncating the z-axis so we don't need it anymore. So we're calculating the cursor direction by taking the cursor position minus the player's translation, which is basically a direction to function in Godot, if you know what that is. And then we're getting the angle by simply using the angle between function, between player direction and cursor direction. And by the end, we are rotating the player in the z-axis by this angle. Yep, that's a lot to unpack. Alright, so the local Y seems to be the wrong axis for me, so I'm gonna use local X. I'm so glad that this works. It's been literally 2 hours, my friends. I didn't think this system would be this complicated. You know what frustrates me? This is very simple logic. What I struggled with most here was Rust and Bevy itself. 2 hours made me feel completely stupid, but let's not lose focus here. We only have one more function to create. Fn shoot. So I think we're gonna need the commands for this one. We also need the button resource, which is the same one we used for keyboard, but instead of key code, we are now getting mouse button. If buttons, button, just press, mouse button left. I guess we spawn a bullet. I have this bullet.png, commands.spawn, right bundle, texture. This is the part where we need the asset server. Load bullet.png, defaults. We will now create the bullet entity and a move bullet system. This is me trying to understand DCS. It's very confusing so far. So for every transform with bullet, we're going to create the direction based on bullet.local x. I also forgot to add bullet. Here we're supposed to spawn a bullet. And the speed, I think it's going to be close to 800. And I want to move in that direction. We have to do transform.translation plus equals direction times bullet.speed. And just to make this extra good, we're going to use the time variable and multiply by delta seconds. Then in our update logic, we're going to add the shoot and the move bullet, and we should be able to spawn bullets from the center of the screen now. Yes, we can. So now I believe we need the player. So at a basic level, we can actually get the player here with a simple query. Transform with player. Yep, so for transform in player, let mute player transform player transform equals transform. I might be screwing this up. And then I bring this down here. Let player pause equals player transform dot translation player pause dot x dot y. This can be 0. Interestingly enough, I think this should be -1. Oh, what's the problem here? I'm just putting the ampersand everywhere. Of course, that doesn't work. Okay, so I'm just going to initialize this. I don't care. Okay, apparently I have to initialize everything in Rust. I hope I'm correct on this. You can feel free to correct me in the comment section. One more change to the target transform is its rotation is actually going to be equal to the player transform dot rotation. Alright, I had to make this mutable. Man, this is so confusing for me. But anyways, now we just gotta do transform, target transform, no errors detected. Okay, this is actually pretty cool now that it's working. Okay, I'm just going to make the bullets smaller. So just take the target's scale here, and I'm gonna make this 0.3. I keep thinking this is Godot. Hey, look at this. Man, this feels so relaxing now that it's working after 5 hours of misery. So we learned how to create timers in the getting started section. I actually think I'm going to create my own timer here. And this is actually going to be fire rate. So my fire rate for the weapon. So we include it here. And this is the if statement we need. Rate timer. All we gotta do now is insert this as a resource. Fire rate, timer from seconds, duration, 300 milliseconds, timer mode, repeating. We also need time here. So we can now hold down our mouse button and shoot at a steady rate. I actually think I want this to be 15 or 115 milliseconds. Yep, that's pretty fast. And well, I think that concludes our Bevy journey, my friends. I know the result is not impressive, my friends, but as you probably noticed, this, I've spent 5 to 6 hours to create this. That's because I never used Rust and I never used Bevy before. That's also because I watched no tutorials and decided to go with Google for my best friend here. I didn't use ChatGPT and I watched no YouTube tutorials. I did use Stack Overflow and Google a lot, but that's normal, I think. So how do I rate this experience? 7 out of 10, would kill myself. No, but in a more serious note, this was actually pretty cool. I actually learned a lot about Rust and programming, and I recognized that almost every problem I faced was due to my own ignorance. And for everyone that's complaining that the bullets are coming from my guy's body, that's not a bug, that's a feature. You don't know where the bullets are coming from. Oh, by the way, if you want to learn how to code, there is a fast and interactive way. You can even do it in your spare time. I'm talking, of course, about Brilliant. They are sponsoring today's video, but I'm a big fan of hands-on learning, and that's the best kind of hands-on learning you'll get. Their main approach is letting you play with the problems, which is proven to be 6 times more effective than watching lectures. And if you don't have much time, learning a little every day this way is still very effective. You can also access Brilliant on your phone, so you can learn on the go. They have a big range of topics that goes from data to math, but if your focus is programming like me, they have a growing number of programming courses. You can get familiar with Python, learn the essential coding elements like loops, variables, nesting, and conditionals, and develop your mind to think like a programmer. So if that piqued your interest, scan the QR code or visit brilliant.org/Freddy and you will get a full 30 days for free and also a 20% off on the annual premium subscription. Seriously, go check it out.